This conference will now be recorded.
So yesterday we were discussing about what is pod autoscaler. We had to create a autoscaler. We just deployed metric server. So let me connect to my machine where I have a kubectl installed. We'll try to continue from there. So we installed metric server. You can see metric server is installed. I think my machines also have a problem now. Since we deployed lot of applications, you can see. Since we deployed lot of applications, we can see already my nodes are not ready. Because of my nodes are not ready, this metric server is also running in one of the node that is also in not able to run successfully. So let me do one thing. Let me delete all the applications in current namespace, in a default namespace. Let me stop and start these worker machines with very less capacity of servers. With very less capacity of servers, I cannot run. So I'm stopping these two worker machines and I'm going to start again. So let me delete in that test ns namespace also. Test ns namespace. Guys, don't delete anything in the Kubernetes, the kube system namespace. Okay, when you are having these kind of issues, don't delete anything in kube system namespace. Okay? So let me do this. Meantime, let me explain what is that HPA. Let it start the servers in the background. So we already installed metric server. Metric server is going to gather the metrics from kubelets, and it is going to available as an APIs for other services like horizontal pod autoscaler. So in horizontal pod autoscaler or vertical pod autoscaler we can do, but the widely used one is horizontally scaling the pods. Horizontal pod autoscaler will programmatically adjust, it will increase or decrease number of replicas of a given deployment or a replica set or a replication controller. So horizontal pod autoscaler automatically scales the pods, the number of pods of a replication controller, deployment or replica set based on the observed CPU or memory utilization. This horizontal pod autoscaler also one Kubernetes resource, one API. So this horizontal pod autoscaler will periodically adjust the number of replicas of a replication controller or deployment or a replica set based on the observed CPU and memory utilization against targets specified by the user. We will set some threshold value. Based on that threshold value, the moment the current pods has reached that threshold, this HPA will increase the pods automatically. And also whenever there is no load, it will decrease the pods automatically. So HPA will interact with metric server, metrics API to identify CPU and memory utilization of the pod. So as I already told, metric server will gather the metrics, resource metrics from the pods, nodes, right? So we need to have this metric server deployed. Then we can have a horizontal pod autoscaler created. So for any deployment, for any application, any deployment, or for any replica set or replication controller, we can create a horizontal pod autoscaler object. That horizontal pod autoscaler object will increase and decrease the pods based on the threshold value, whatever we are going to set. That can be for any deployment. I am taking this as an example. For this application, for this deployment, we are creating a horizontal pod autoscaler, something like this. We are creating a horizontal pod autoscaler, something like this. This is again one more object. So here we are defining the threshold values. Here we are defining a threshold values. If average CPU utilization reaches 40%, then it will scale. Or memory, I can say something like 80% memory or 80% CPU. These are the threshold values. So the moment reaches average, let's say 80% of CPU utilization and 70% of memory utilization, something like this. This will adjust the replicas. This will adjust the replicas. This horizontal pod autoscaler can be created for any application. Right? First, let me show you without having this horizontal pod autoscaler. We are just going to have a deployment. We already deployed. We will not have a horizontal pod autoscaler. If we don't have a horizontal pod autoscaler, will it scale automatically the pods even though there is a load? If you don't have this horizontal pod autoscaler created, will it scale the pods automatically even though there is load? No. Let me show that. Let me start these servers back. We can create horizontal pod autoscaler for any application. Just I'm demonstrating using this sample application. I'm demonstrating using this sample application, one sample image. So we are creating a deployment. You already know what is deployment. We are deploying one application, one image, right? Using this image, we are creating one deployment with the two replicas. For this container, what is this? What we are defining here? What is this? Whatever I have highlighted. The resource for that container. If I want to have a HPA, horizontal pod autoscaler, or vertical pod autoscaler, do we need to set some kind of a limit and request? Because it is going to calculate the average. So do we need to have limits so that based on this limit, it can calculate currently what is the load, right? So if you want to have a HPA created for any deployment or any replication controller, do we need to define resource request and limits to calculate the average, this threshold value, this threshold value? Yes. So we are saying I need this much CPU, this much memory, limit is this much, memory limit is this much. Now, if I say average is 40% CPU, I can define only on the CPU, or I can define only on the memory, or I can define on both. Now, let's say average CPU utilization threshold value, I have said percentage 40. So 40% in the sense, out of this limit, 100 millicore, the moment it reaches 40 millicore, then will it consider the utilization is high? The moment the load, the CPU utilization reaches 40%, the limit I have set as 100 millicore, the target average I have set 40, which means if the moment it reaches 40 millicores, will it be considered as a utilization, the threshold value is met, then will it scale the pod? The moment it reaches the threshold value, it will scale the pods. Now, if I say memory is 70%, so what is the 70% of out of this limit? I have said limit as 256 megabytes, just to give an example. So the 70% of 256 is approximately the moment it reaches 190, or approximately close to 200, approximately 190, 180 of megabytes. It will be considered there is a high memory utilization. So what is this? While creating a horizontal pod autoscaler, we are saying threshold values. These are the threshold values. And what is this min replicas, max replicas? What does it mean? What does it mean? Irrespective of the load, irrespective of the load, minimum how many pods it will maintain? Irrespective of the load, always minimum how many pods it will maintain? 2 pods. Whenever there is a load threshold, whenever the condition is satisfied, average, then it can go to, it can go up to how many replicas? It can scale up to how many replicas? Up to 5. Will it scale beyond 5? Will it scale beyond 5 if I give 5 here? No. So minimum it will maintain whatever I have given. Whenever there is a load, it can scale up to 5. But again, do we need to have enough CPU and memory in the cluster to scale? Again, if you don't have this much CPU and memory available in any node, will the parts will be come to running state again? If you don't have enough CPU, enough memory available in the cluster, it will try to scale the pods, but pods will be in a pending state. But provided you have enough CPU and enough memory in the cluster, will it able to increase and decrease the pods automatically? This horizontal pod autoscaler programmatically, will it adjust the numbers based on the current trend, current load? Yes. Now we are creating a horizontal pod autoscaler, but for which one? Which object it has to scale? Which deployment or which replica set? We have, it has to scale. Where we are defining the target? Which target, for which target we are creating this horizontal pod autoscaler? Where are we defining that? Here. Scale target reference. Scale target reference. So this horizontal pod autoscaler is for this deployment. The name I have given has this. With this name, we have one deployment, right? So this horizontal pod autoscaler is for this deployment. Like this, can I create a HPA for any deployment, any replica set also directly if you are creating a replica set directly, or replication controller? Can I create a HPA for any deployment, whatever I am trying to deploy in my Kubernetes? We can create for any application. It will automatically scale. It will increase and decrease the pods whenever there is a load. With this way, with this HPA, can I make sure I will have enough number of replicas available for my application to serve the traffic whenever there is a load? Yes. Okay. Now, let me deploy this application. First, I am deploying this one only without HPA. But before that, let's see my nodes are ready or not. My nodes are fine. My nodes are fine. All the nodes are fine. And I have a metric server also. Metric server is gathering the metrics. Metric server is gathering the metrics. Now, let me deploy this application. This is one sample application which I am using. I'm just creating a deployment, normal deployment. You already know the deployment. For this deployment, we are creating a service. We are creating a service. If I want to access this application from outside, what type of service I can create? If I want to access from outside this application, node port. If I want to access only inside, if I want to access only inside cluster IP. If I want to access from outside, node port. Now I am not creating a HPA for this application as of now. Let me show that. I'm applying this one. So my application pods got created. My application pods got created. To access that application, I created a service. To access that application, I created a service. Now it is pulling the image to create a container, so it will take some time. Now my applications, my pods are up and running for this deployment. Now, if you see, I'm getting a response. Within the cluster, I'm using this IP, or I no need to use this IP also within the pod. If one pod communicates with other pod, we already discussed. One application want to communicate with other application in Kubernetes in same namespace. Can it use the name service name? Suppose if I have another pod, another application, can it communicate with this application using this service name? Yes. But if one pod in one namespace want to communicate with other pods, other applications in other namespace, in that case also we can use service, but service with what? FQDN. What is FQDN? Fully qualified domain name. Now I don't have a HPA created. If you see, do I have any HPA? HPA. HPA stands for horizontal pod autoscaler. Did I created any HPA in this namespace where I deployed my application? No. Now, even though there is a lot of load on this application now, even though there is a lot of load on this application now, will it increase and decrease the pods automatically? No. Let me show that. Now, how can I increase the load? If you see, as of now, how much current CPU utilization? Because no one is accessing this application. What is the current CPU utilization on this pod container? On this pod container? Since there is no load, since there is no load, just 1 millicore. Now, how can I increase the load? Basically, there will be a kind of some testing in real time, like performance testing, stress testing. They can use some tools. They can use some tools. The testing team, the performance testing team, they can use some tools to programmatically increase the load on these applications. Like if it is a APIs, they can use JMeter or load runner. Anyone from testing background? Did you heard about load runner, JMeter? So we can increase the load using some tools. For now, can I increase the load programmatically using some kind of a script, shell script? I will infinitely execute. I will infinitely access this service using some shell script. If I infinitely do the curl or wget on this service, will the load will be built up on these pods? I want to programmatically increase the load. I can't ask 1,000 people, 2,000 people to access my application. I want to test. So programmatically, I will increase the load. Programmatically, I will increase the load. Now, I'll create some temporary pod. I'll create some temporary pod. Using command itself, I'm creating kubectl run -i -t -rm, right? Something like this. I'm creating a pod temporarily using this image. Using this image. This is one image. Like this kind of a just container libraries. It will have a wget package as part of this image. I'm creating some temporary pod interactively just to put the load, something like this. Something like this. I'm creating a pod, a run, kubectl run, right? Something like this. I'm giving some name, that's it. Load generator. This is the name of the pod. What is -it stands for? Now I am interactively creating. What is this -it stands for? Here I am using -i -t interactive terminal. What is this -rm? What is this -rm? Basically, once I come out of that pod, it will delete the pod. It will remove the pod automatically. -rm stands for remove. Once I come out of that pod, the pod will be removed. This is the name of the pod. From this image I want to create interactively. So I can execute something like this. -bin/bash or directly like this bin/bash. So I'm creating a pod interactively and executing this command. Now I will go inside this pod once the pod is created. Now I am inside this pod. Now, if you see, am I able to access that application via service name, whatever name, with whatever name I have created, let's say this name, service name. Am I able to access that application using service name from other pod? Am I getting the response? This is one temporary pod. I am inside that pod. Am I able to access that application via service name within the one more application? Am I getting the response? Now, if I do this infinitely, will the load will build up? Will the load will be built up on that application? Let me do that. Let me connect to the same machine where I want to show what is the load. Okay, let me connect to the same machine. Same machine where I have a kubectl installed. Same machine where I have a kubectl installed. I'm connecting to the same machine. You do this now. In this, I'm trying to see, I'm executing a watch command. What is complicated? Srini is saying it's so complicated. What is complicated here? I just deployed one application. I just created a service for that application. I'm trying to access that application from another application, another pod. What is the complexity here? What you are not able to understand here, if you tell me, I can again, what you are not able to understand, I will try to explain again. I just deployed one application. I created a service for that application. I'm trying to access that application from another application, another pod, using that service name. So here, let me show you. Since there is no load, as of now on this application, the CPU utilization is very less. Now we have only two pods. Now here, if I programmatically increase the load, something like this. What is this, guys? While true. What is this? From the temporary pod, what I'm trying to do now? What is this? You learned Linux. What is this? While true, do, done. In an infinite loop, what I'm trying to do? In an infinite loop, I'm trying to access that application from that this temporary pod. From this temporary pod, I'm trying to access this application infinitely. Now, will the load will be built up? Request goes to the service, Kubernetes service. Service has how many pods as of now? Service has how many pods as of now? Only one. Huh? What is this? Because he's saying three. Three pods we have for this application. Three pods we have for this application. Only two pods for this application. So does service will distribute the load? I'm using a service. So does service will distribute the load between these two now? Even though I'm trying to access infinite loop, will it distribute the load? It will distribute the load. Let me press enter. Let me press enter. Now slowly, in an infinite loop, we are making this call. We are trying to kind of putting the load. Now do you see already the CPU utilization went little high? Now, I don't have a HPA. I don't have a HPA created, horizontal pod autoscaler created. Will I get a third pod? Will I get a fourth pod? Now you can see already 61%, sorry, 61 millicore has been utilized. Here 45 millicores has been utilized. What is the limit I have set for CPU? For this pod, for this container, when I am creating, how much I set? Limit? How much CPU have set? 100 millicore. So even though there is a lot of load, will it go beyond this much 100 millicore? No. Now, if the load is keep on increasing the load, keep on increasing the load, does application performance will be impacted? If it is running out of CPU, do we get a faster response? You will not get a faster response. Application performance will be impacted. If it is running out of memory, what will happen? If it is running out of memory, what will happen? The process will be crashed. Even though process is crashed, even though container is crashed, since we have a controller to recreate, will I get another pod? Even though process is crashed, we'll get another container. But does it solve the problem? Even if there is a lot of load, if the container goes down, recreate, will it solve the problem? No. So what needs to be done? Again, it will work for some time. After some time, again, it will crash. So whenever there is a load, what needs to be done? We need to scale, but I don't want to scale manually. I don't want to scale manually. What is the meaning of manual scaling? Can I execute kubectl scale command, or can I change the number of replicas in my deployment manifest and apply again? That is manual scaling. I don't want to scale manually. If I want to automatically scale based on the load, in that case, can I create this HPA object, this horizontal pod autoscaler? Do we have, as of now, do we have horizontal pod autoscaler? No. If we have a horizontal pod autoscaler based on the threshold value, I would have got another pod. I would have got another pod. So we don't have a horizontal pod autoscaler. Let me stop the load. Let me press Control C. Let me press Control C. Let me come out of this temporary pod. That pod will be deleted. Now let me create a horizontal pod autoscaler also. I'm going to have this one also created, horizontal pod autoscaler. Something like this. API version, this one, kind horizontal pod autoscaler. How to know what is the API version if you don't know? Can I do this? kubectl API resources. If you see API resources, horizontal pod autoscaler. So this one, auto scaling slash v1, I think they have changed, or you can use this one also. This is kind of a beta version, beta versions. You can have this one, or auto scaling slash v1. If that Kubernetes version doesn't support this one, you will get a message. unsupported version. So auto scaling slash beta versions you can use, or you can use something like this v1, right? So I am using this beta version. Now let's say why I am taking 40%, because I cannot put lot of load. I cannot put lot of load. That's why I'm setting 40%. But in real time, what will be the ideal thresholds you set for your pods, right? Approximately 70 to 80. In between 70 to 80, you will set the threshold values. In between 70 to 80, you will set the threshold values. Okay. I cannot put that much load. That's why I'm just keeping 40 here. Okay. I can put only on the memory, or only on the CPU, or on both. On both. Now let me create this one. Now I already have a deployment. This is my deployment name. This is my deployment name. Suppose here my deployment name is ABC. So here my the scale target reference, this name, the scale target reference, this name should be also APC, ABC. Okay. So now my deployment name is this. I'm giving this. Suppose my deployment name is ABC here. Here also I will give her, this scale target reference name as ABC. So I am giving the the conditions on both CPU, resource name CPU, utilization average, memory utilization average, both. Right? Now with this, let me apply again. Let me apply again. Now this time, do we have a HPA also? Horizontal pod autoscaler. It is still calculating what is the current utilization. It is still calculating. I can see now. Now what this is CPU. What is the average current utilization? It is average. Average in the sense sum of current replicas, by total replicas, total current replicas. So when it calculating average, how much it is coming? Average CPU for this deployment 1% currently. Memory. So 19 plus 1, 19 plus 1, 30 by 2, somewhere around it is calculating 70% threshold value 24. So 256 we have given, 256 we have given the limit. When it is calculating the average of the 256, it is somewhere around 24% it is coming. Now there is no load. So minimum pods I have given 2, maximum pods as 5. So now since there is no load, how many pods we are, it is maintaining as of now? Since there is no load, 2. Now if I increase the load, I am opening another shell. I am just opening another shell just to show you what is happening in the background. Same Kubernetes machine, same master machine I am connecting, where I have a kubectl installed. Same machine I am connecting to show what is happening in the background now. Now if you see kubectl get HPA, currently how many replicas are there? Minimum pods is 2, maximum pods is 5. Replicas in the sense currently how many are there as of now? Only 2, right? Let me watch this one also. This watch command will execute this command, next command, for every 2 seconds it will refresh. Every 2 seconds it will refresh. Now again, if I put the load, now, will I get a third pod automatically? When it is average reaches that 40% CPU utilization. Now let me create again temporary pod. Let me create that temporary pod again. Let me create the temporary pod again. Like this, we created a temporary pod. Now I'm executing that command. Now you observe average, guys. It will calculate average. If only one pod has a 45% and another pod has 20%, will it create a third pod? One pod has a 45%, another pod has a 20%. In that case, will it calculate? It will calculate the average. Then it will scale. If the average reaches 40, then it will scale. Now if you see, now it is already, what is the average now? Is it cross the threshold value? 41, 61, 43, 104 by 2, something like this, 52%. Now do you see, already I got a third pod, replicas as 3 here. It is showing replicas as 3 here. Here I will see after some time, here also it will reflect. After some time, I can see third pod here. We already have a one pod, third pod got created. Do you see who created this third pod? Now I can see 3 pods for that application. Who created that third pod? HPA. Even after having 3 pods, if the average goes beyond 40, will I get another pod again? Now since we have a 3 pods, we are accessing that application via service. Service is distributing the traffic. Now average 50, 43, 14 by 3, 50, 34, 24 by 3 average. If the average goes beyond 40%, then it will create. Even after having 5 pods, if the average is more than 50%, will it scale to 6th pod, 7th pod? We already discussed. It is not going to beyond that one, because what is the max pods you have defined for HPA? 5. Suppose if I have max pods as 10, it can scale up to how many pods? It can scale up to 10 pods. So with these kind of features, will I able to have a more replicas, more instances for my applications, more replicas, more pods? If I am deploying my application as a pod using Kubernetes, using this HPA concept, whenever there is a load, will I able to increase and decrease the number of replicas to serve the traffic based on the load? These kind of features we have in Kubernetes, advanced features. Now if there is no load, again, if there is no load for some time, again, how many pods it will maintain? Will it maintain 3 pods again? Now I have 3 pods. Again, will it back to normal? Now let me stop the load. Now average is not more than 40%. So average is not more than 40%. I'll not get a 4th pod. Now let me stop the load. Let me press Ctrl C here. Let me exit. After some time, if the load is not there, that much load, after some time, now there is no traffic going to that application. So slowly that utilization comes down. After some time, how many replicas I can see? How many pods I can see if there is no load? We can see only 2 pods, 2 replicas. Now since there is no load, right? You can see after some time it will scale down. Who is going to execute that scale commands in the background? We are not executing manually. We are not making any API calls. Who is going to make that API calls in the background? HPA, that horizontal pod autoscaler. So we are going to have horizontal pod autoscalers created for our applications to scale up, scale down whenever there is a load. Now, not only for this application, for our own application also, for our own application also, this is just a demo application. Let's say we deployed this application. We deployed this application yesterday. Can I create a HPA for this application also? We deployed this application. I can define resources for this, something like this: requests, limits, requests. I'm saying memory this much. I'm requesting this much minimum. I'm saying I need at least 200 millicore CPU. Now limits, I say it can go up to half core, 0.5 in the sense half core or 1 core, or I can say 500 millicore. 1000 millicore is 1 core. Memory, something like this, 512 mi. Now I created a deployment with something like this. Now for this one, can I create a HPA? For this one, can I create a HPA? Something like this: horizontal pod autoscaler, some name. I'll say Java Web App, HPA, some name. That information, that one. Now here for this deployment, scale target reference, this deployment. Now I can say something like this, whatever it is. Now I'm creating a horizontal pod autoscaler for this deployment. Again, whenever there is a load on this application, will it increase and decrease the pods for this deployment? If I do this way, if I create a deployment for this application, I'm creating a HPA also for this application. Is it going to scale up, scale down the pods based on the load for this deployment? Yes. Now you see still how many pods are there? Someone is asking, sir, is it scaled down to 2? It is going to have some waiting period, some grace period. As of now, how many pods are there still for that application? 3. If there is no load for some period of time, you leave it as is. You come and see here after 2-3 minutes, after 4-5 minutes, how many pods I can see. I am not doing anything. I am not executing any command here. After 2-3 minutes, after 4-5 minutes, if I come and see here, I can see only 2 pods. So who is going to take care of that one? We have a HPA, this HPA. So this HPA, now itself you can see, did it scale down now to 2? Do you see it scaled down to 2 now? Current replicas here, other side also, I am getting a HPA. Currently, how many pods are there? Current replicas? 2. Now, who is taking care that increasing and decreasing? I am describing that HPA. Do you see? When I describe that HPA, can I see something like here? 8 minutes ago, new size is 3. What is the reason? The CPU resource utilization above the target. 8 minutes ago, the average went above the target. So the new size is 3. It has increased to 3. Now new size is 2. Now new size is 2. 34 seconds ago, it has successfully rescaled. New size is 2. Reason, what is the reason? The reason is below the target. Below the target. All metrics are below the target. So this way, again, if I put the load, will it increase? Again, if some people are accessing this application, there is lot of load on this application again. Will it increase again 3, 4 based on the load? Yes. With this concept, is it possible to make sure our application is highly available, our pods are highly available, and also whenever there is a load, it will increase the pods so that there will be performance improvement also. There won't be any performance impact. When there is a load, we will have more replicas. The performance also not degraded. At the same time, your application will be highly available. Now, if required, can I create a HPA for this application also? As I told, we have this deployment. For that deployment, can I create a HPA something like this? This application. I will define the resources for this application. This container, resources, requests, limits. I'm just saying you can take initially 200 millicore or 100 millicore based on the resources you have in your cluster. Memory, I'm saying this much minimum. Limits, it can go to 200 millicore, let's say. Memory, it can go to up to 512 MI, something like this. Now for this application, can I have this HPA? Something like this. Horizontal pod autoscaler, some name, the scale target, the scale target is this much. The scale target is this much. Now let me deploy this application. One more question, guys. Now here I am giving replicas as 3. I'm giving replicas as 3. It is not a deployment, it's a replica set. It's not a deployment, it's a replica set. So let me change it to replica set. Deployment. Or here scale target reference. The scale target reference should be also replica set. Or you have to have this as a deployment, or make it this as a replica set. This scale target reference. And again, is the name is matching? This is my replica set name. Here the name also should match. Something like this, right? Maybe you can create in whatever namespace you want to create, maybe in the default namespace. Whatever it is. Now here my question here is, in the replica section I have given replicas as 3, but here minimum replicas I have given is 2. So how many parts will be initially created now? Replicas I have given as 3, min replicas for HPA I have given as 2. So this is some type of interview question. Now how many parts it will maintain initially? Now Will it maintain 3 or it will maintain 2? It will create 3. It will create 3. If there is no load, will it bring down to 2? Because initially there won't be any load. In that case, will it bring down to 2? Yes. So if you are creating a horizontal pod autoscaler, does it make any sense to mention these replicas for a deployment or replica sets? If you are creating a HPA, does it make any sense to mention these replicas for your deployment or replica set? No. Even though I don't mention, since I'm creating a replica, HPA, even though I don't mention now how many it will create initially, 2. Let me show that. Let me apply this one. Now, if you see this HPA, where is that HPA? Horizontal pod autoscaler. Minimum pods I was expecting 2. It is still creating. As of now, we have only 1 pod. After some time, I can see one more pod, but it is creating 3 pods because the load might be initially it is going to take lot of CPU. It is going to take initially a lot of CPU. If you see already it took lot of CPU. Initially it took lot of CPU. That's why it created 3 pods first of all. First it has created 2 pods and average is already more than that. Average. So that's why it created 3, another pod, 3 replicas. Even though I have given 2, why I have 3 now? Because the average is very high. So I need to request more CPU, more memory. Because Tomcat takes more CPU, more memory initially. Maybe I should have requested something like this. 500 millicore is the minimum limit. I would have told like 1 core CPU. Then here I would have defined something like this. You got why it is creating these many pods while applying itself, even though I have not put the load. Do you know why it is creating these many pods? Why it has already created 5 pods? If you see the CPU, while starting the application itself, while starting it has took lot of CPU. While starting the Tomcat, it took lot of CPU initially. That's why it has created those many pods. Initially. Once the Tomcat is started, again it came down. Now the average will be very less. If you see, now the average is less than the target. This is memory utilization. This is CPU utilization. Now average is less. It will bring down those pods. Okay. But again, whenever there is load, will it increase the pods for that application? This whatever application we deployed, this application. Now, if you observe why these two are showing as pending, even though HPA has created those pods when there was a load, why these two are showing as pending? Any idea? What could be the reason? HPA tried to scale, but why it is showing as pending? What could be the reason? Because while creating these pods, I am requesting some CPU, some memory, something like this. So do we have that much resources available in the cluster? Do we have that much resources available in the cluster? That's why it is not able to scale. So even though HPI is trying to scale, if you don't have enough CPU, enough memory, will parts will be created in your cluster? I mean to say, will be up and running. Parts will be scheduled, but will it become running state if you don't have enough nodes, enough CPU in your cluster? No. Is it scaling the nodes? Is it going to scale the nodes? Does Kubernetes does the scaling of the nodes, the servers? No. This pod autoscaler, only scales the pods. But if I go for a managed Kubernetes clusters, guys, if I go for a managed Kubernetes clusters, like EKS, AKS, GKE, IBM Kubernetes engine, managed Kubernetes clusters. In case of managed Kubernetes clusters, who is going to manage the nodes? Who is going to manage the nodes servers? Your control plane will be managed by whom? And your nodes, that Kubernetes nodes also managed by whom? The service provider, the provider. So if I go for a managed Kubernetes clusters, in managed Kubernetes clusters, can I have this node autoscaler also? The way we have a pod autoscaler, can I have a node autoscaler also, which will scale the nodes? But who will do that? Does Kubernetes does that, or cloud, that provider? That provider will increase and decrease the nodes? The cloud. So sometimes in the interview they'll ask, what is pod autoscaler, what is node autoscaler? Pod autoscalers, can I achieve pod autoscaling in a self-managed Kubernetes cluster or managed Kubernetes cluster, whatever it is? Can I achieve pod autoscaler in any kind of a Kubernetes cluster, like self-managed or managed? Yes. But when it comes to node autoscaler, will I able to achieve in self-managed Kubernetes clusters like our own data center servers? No. That is manageable by provider. So node autoscaler will scale the nodes. If it is running out of resources, your cluster is running out of resources, node autoscaler will scale the nodes, but pod autoscaler only scale the pods. So this node autoscaler, I will demonstrate when I go for a EKS. I will explain EKS. That time I will demonstrate this one also. Suppose this is managed Kubernetes cluster. Let's consider this is managed Kubernetes cluster. Consider this is a managed Kubernetes cluster. The moment my cluster is running out of resources, the moment some pods are in a pending state, because of no resources available, if I have this node autoscaler also configured in that cluster, will I get another pod? Suppose this is managed Kubernetes cluster. If I have this node autoscaler also deployed and some parts were in a pending state, in that case, I would have got another node automatically. That I will demonstrate when I go for a EKS. Very, very important concept, guys. Pod autoscaler and node autoscaler. Are you clear what is pod autoscaling, what it will do, what it will not do? and what is node autoscaler. So we are going to use all these concepts in our real-time projects, right? We will have a pod autoscalers to scale the pods. And if it is a managed Kubernetes cluster, you no need to create a upfront lot of nodes. You no need to create a upfront lot of nodes also. If it is a managed Kubernetes cluster, I can just have a node autoscaler configured. It will scale the nodes also whenever it is running out of the nodes. This node autoscaler in the background, it will communicate with what what service in cloud. In cloud, do we have one service called autoscaling groups? Do you have one concept called autoscaling groups? So this node autoscaler will communicate with autoscaling groups. It will increase that minimum nodes, maximum nodes are there, right? Minimum nodes, maximum nodes, the desired nodes. This node autoscaler will adjust the desired nodes for a autoscaling group. So in that case, that autoscaling group will create another server. I will discuss this when I go for a use case. But if it is a self-managed Kubernetes cluster, do I need to have a upfront enough servers in my cluster, enough CPU, enough memory available in my cluster upfront to scale the pods automatically? Yes. So this is what pod autoscaler. Okay. Now let me delete these applications. Let me delete these applications. Why I am deleting? To demonstrate other application, because my cluster is having very less resources. If I keep deploying lot of applications, without defining resource request and limits, will it cause the issue? If I define resource request and limits, it will not cause issue because pod goes to pending state. But without defining resource request and limits, if I am keep deploying the applications in this cluster, will it cause the issue in my cluster? Servers goes down, your applications goes down. So that's why I'm deleting these applications to deploy. Now let's try to understand next concept, volumes. Now let's say I'm trying to deploy some stateful application. If the pod is deleted, if pod is deleted and recreated, will the data will exist? No. So Pranesh is asking, when I'm using self-managed Kubernetes in cloud, I can configure auto scaling instance with customized. You need to create a launch template. In the launch template, you need to make sure you need to install all the required softwares to set up Kubernetes, and you can create auto scaling groups. So auto scaling groups will manage your servers. But instead of going that, you can directly go for a managed Kubernetes cluster. You no need to do anything. They are going to create the cluster for you. If you are already in the cloud, you no need to do yourself. You go for a EKS, they will take care of everything. If you are already in a cloud. So now let's try to understand this volumes concept. Now in Kubernetes, we are creating a pods. Pods are nothing but again containers. Suppose I am persisting some data in the container storage. If the pod is deleted and recreated, do we have the data? No. In that case, we need to use volumes concept. Now let me deploy this application, this Spring Boot application, this application, which we already deployed in Docker and Docker Swarm also. So if I want to deploy this application, we have two images. We already created an image for this front-end code. This one. This image. We already created an image for this application. Mongo database as a database, kind of a database. Another image for a database. So backend can be database or backend can be another application also, guys. Let's say if you take this three-tier architecture, let's say you take a three-tier architecture. What is the meaning of three-tier architecture? Front-end, backend, and database. UI. People can develop the front-end, whatever we see in the browser, that is front-end. That front-end code can be developed using HTML, CSS, JavaScript, or React.js, something like this. Some code is there. So you can have front-end separate, you can have a back-end separate. What is the meaning of back-end? Back-end can be like a Java code, APIs. Back-end can be developed using Node.js. Back-end can be developed using Python. Back-end can be developed using .NET or Go language, PHP, like this. And this backend can connect to the database, DB. This is three-tier architecture, right? So front end will invoke this data, this code, dynamic code. This code, this application will talk to the database, something like this. This is three-tier architecture. Now, whatever application I have, this application, within this application itself, I have a front end and a back end. I mean to say dynamic code and that UI code also. So this Spring Boot application, I have a Java code. The dynamic code, the backend code, and also I have JSPs, HTMLs, this front end. So in same project, kind of a both. Now this application is talking to the database. So what database this application is using, whatever I am demonstrating, this application is using what database, which we already deployed a lot of times. What database it is using? Mongo database. Now I have this image in this code, right? I have a front-end code like HTML code, and also I have a dynamic Java code, backend code. This Java code is connecting to the database to retrieve and read the data. So if I want to deploy this application in Kubernetes, first of all, do we need to create a image, Docker image, container image? First of all, if I want to deploy this application in Kubernetes, do we need to make sure we have an image created for this application? Without having an image, can I deploy that application in Kubernetes? We are creating a pods. Pods will have a containers. Container is created again from what? Image. So I already have an image. I already have an image. Image is part of my registry. Can I deploy this application in Kubernetes now? This application, I already have an image. Yes. And database. Database, if required, I can run database also as a pod in Kubernetes. Or can I run database outside of my cluster also? Like a managed databases also there. In AWS, you have a RDS, managed databases. Or can I have my database in a separate VM, separate virtual machine if required? In that case, my application is running as a pod. My application is running as a pod container in Kubernetes. I can have a database outside of this Kubernetes also. In that case, will it able to communicate if there is a network connectivity between the VPC in which I have a Kubernetes cluster and the database is also in a same VPC, that virtual machine, or that RDS also in a same VPC. My application is running in Kubernetes, database is running as a VM, or maybe database is running as RDS in a same network. Does my application will be able to communicate with that RDS or VM even though it is running as a pod? Same network, same VPC, it can communicate. If my Kubernetes cluster is in different VPC, my database VM or my database RDS is in a different VPC, what is required if they want to communicate? If they are in two different networks, how can they communicate? I don't want that. Guys, database is not running as in Kubernetes. Database is not running in Kubernetes. I am saying database as a separate virtual machine or database as a RDS instance. How my application, my pod, my application can communicate with the database? That is what I am asking. Here, not, it will not come service with node port. This database is running as a separate instance. This application want to talk to this one. It is not internet gateway Sahana. The databases should be in a private subnets, right? So can I have a VPC peering? If that is database instance is running in a separate VPC, if I am running outside of my Kubernetes, the database, can I use that VPC pairing? If the Kubernetes is in different VPC and the database is in different VPC, I can use the VPC pairing. If required, can I run databases also as a pods if required? Does can we do that also? Yes, if we have images. In that case, if my database also running in a same Kubernetes cluster, can I use services, Kubernetes services concept? Does application can talk to the database using that service name, database service name? Yes. Now, if I am running database also as a Kubernetes pod container, if the database pod goes down and if the database pod is recreated, do we have a data? The database data, if the database pod is deleted and recreated? No. In that case, do we need to worry about the volumes in case of stateful applications? In case of stateful applications, do we need to worry about the volumes? Yes. Now, I want to deploy these two images. Now you tell me what are the Kubernetes resources I need to create. What Kubernetes resources I need to create now? Kubernetes resources or objects needs to be created to deploy this application. Deploy this application. What are the Kubernetes resources? If you understand the concept, this is what we are going to do in real time. We have our applications. We have our applications like this. We have some applications like this. We are going to deploy these applications into a Kubernetes clusters. That is the real-time task. If you understand Kubernetes now, you tell me what and all things needs to be created. How many Kubernetes resources I need to create? How many needs to be created? Is it recommended to have these two containers together in a same pod, or I need to create a separate controller for this one, separate controller for this one? Is it recommended to have both containers, that application container and database container, together in a same pod? No. So in that case, can I create a deployment or replica set for this one? Deployment or RS for this one, for this one. Yes. And again, which is recommended between RS and deployment? Recommended, not mandatory. Which is recommended? Deployment. Why? Because this is an application. Whenever there is a change in the application, I am going to have another image. Do I need to update my application? Do I need to deploy that application? Do I need to update? If I go for a deployment, will I able to update my replica sets? I mean to say my images. Yes. This is database. This is database. You are not going to frequently update the database images because this is database, not an application. So in that case, can I go for a RS or deployment? Anything is fine for this. Now I can go for an RS or deployment. Anything is this. Okay. Now, if I just create a deployment, if I just create a replica set, will it be sufficient? Then what needs to be created? Service. Do I need to create a services to access this one from outside? What type of service I can create for now to access this application from outside? What type of service I can create for this one? Node port. For this one, for this this database should not be exposed to outside. Database is within the cluster. So in that case, what type of service I can create? Cluster IP. Now, this is the image. If I given a task for you to create a manifest files to deploy this application, will you be able to do it? You already know what is deployment, what is service, and also I'm saying you need to pass some environment variables. You need to pass some environment variables. If you remember, while creating a container for this application, did we pass environment variables like database host name, username, and password? And while creating this container also in the Docker, did we pass root username and password for database? So in Kubernetes also you can pass. How can you pass? How can you pass? Let me show you. I'm taking this one. Forget about volumes. Forget about volumes. Forget about volumes. I'm creating a deployment. I'm creating a deployment. Deployment with the two replicas, let's say, for this application, for this image. So I'm creating a, for this image, I'm creating a two replicas. If required, you can mention the CPU, memory, all these things. Now, how can I pass environment variables? Because I need to pass a database host name, username, and password, right? That application, if you remember, is that application is referring that host name, database username, and password as an environment variable in the code. We already aware of this code. So I need to pass the environment variables. So in manifest file, here I can pass environment variable something like this. I can pass environment variable something like this: env, then name, environment variable name. What is the environment variable name this was expecting? If you see the code, it was expecting some environment variables, something like this: MongoDB hostname. This MongoDB hostname, what should be the value? The value should be whatever service you created for a database. If I created a service as Mongo SVC, can I give that as a Mongo SVC here? If I create a Kubernetes service for Mongo database as a Mongo SVC, I can give like this, Mongo SVC. If I create a service with name Mongo for my database, can I give something like this? Mongo, that host name, service name. Similarly, another environment variable, something like this. They are expecting this, whatever username, something like this. Another environment variable for this container. Something like this, devdb @123. Same way, here I am creating a service for that Spring app. Like this. Similarly, do I need to create a replica set or maybe deployment for database this image in same manifest file or different manifest file? Same manifest file or different manifest file, you can create a, maybe if you want to give resources, you can give, otherwise leave it. Mongo DB, Mongo, something like this. Using this image, I am not giving the tag. What will be the tag? What will be the default tag it will use? :latest. And what is the port of Mongo database? Is it 8080? What is the port of Mongo database? 27017. Now, do I need to create a service? Because this front-end application, this application is required to talk to the database. We are passing those details to this container. Do I need to create a service for this database pod also? Here, if I am giving Mongo, service name as Mongo, and make sure you are passing this host name also as a Mongo. If you are having as something like this Mongo SVC, pass this as a host name here. With that host name, it is going to connect to the database. Now I don't need a node port. I need a cluster IP, selector Mongo, this labels, Mongo label. The port is 27017. It is not a web application. Port is also 27017. Target port is also 27017. Now, if I deploy this way, is my Spring application will be deployed as a pods, 2 pods, and database just only 1 pod. I'm not using volumes as of now. But here, for this container also, do I need to pass environment variables to set the database, that username and password? This is expecting different environment variables. Value can be this one, devdb @123, username devdb, but it is expecting different environment variables, that image, something like this. This is the username environment variable. This is the password environment variable. Same username and password is given to the application to connect. Now, if I deploy this manifest file, is it going to deploy that application in my Kubernetes cluster? But before that, let me delete all the applications. Okay. Forget about volumes. I'm not using volumes as of now. I'm just deploying that application. Make sure your indentation is correct. Indentation is correct. Make sure your indentation is correct. Now with this, I'm trying to deploy my application. I have not defined namespace for anything. So in which namespace all these pods services will be created if I apply this YML? There is an indentation issue at line number 21. There is an indentation issue at line number 21. Line number 21. There will be some hidden spaces will be there, guys. Now 23. There might be some hidden spaces, hidden tabs that you need to fix. Now I am giving this as an assignment for today. I want you to deploy this. I want you to make sure your Spring application is up and running. Your database pod also up and running. Your front-end application should be able to talk to the database. Forget about the volumes. I am not going to share this manifest file. I want you to deploy this application, and I want you to successfully access the Spring Boot application. And if you insert some data, it should go and sit in the database, so that you can understand. That is what we are going to do in the projects. There will be some applications, that applications has to be deployed in a Kubernetes. Will you do that assignment today? I am not sharing this manifest file, but you know what is deployment, what is service, everything. And try to practice whatever has been discussed also, HPA, horizontal pod autoscaler, and try to deploy this application. I want you to share from the browser. I want you to see, you should be able to access that Spring Boot application. I should see some records here, the database records. That is the assignment for today. I'll continue tomorrow with volumes. Okay. Thank you, guys. I'm stopping the session for today. We'll see you tomorrow.